Good afternoon, everyone.
Good afternoon, sir.
Uh, you have all your assignments completed, right?
Yes, sir.
Your 1 to 8 assignments date is done, right?
Yes, sir.
Okay. So this class basically, when is your exam?
Sir, tomorrow.
Tomorrow only your exam is there. Final exams.
Yes, sir.
Okay. Then basically in this class we will have some doubt sessions only. कि whatever doubts you have, we can clear it, right? Because I have nothing to teach you in this session. Because already we have like seen every I have done the revision of every 8 weeks, right? So and we have also discussed different questions before your assignments. So now every assignment has been completed and everything has been done. So tomorrow is your exam. So please, if any doubts are there, we should take that and we should complete that now. Hello. Hello.
Yes, sir.
So can we please, you have any doubts so we can go forward. Like what you want? You want me to share the PPT so that you can see it again because it has all the 8 weeks content. Also, you can access the PPT. You have the link to access the PPT, right? Which from which I am teaching. Hello, uh, Arunima, right? See, like there is the important questions what you have covered in the assignments, na, that are all important. If you have done your assignments well, then it will be very easy for you to solve the exams. As such, I also don't know about any important questions. The questions are all set by the professors. I can just suggest that whatever assignment question you have, you practice it. You just see it before going, because assignment question cover each and everything, each and every formulas and each and every concept the assignment questions they have covered. So just see the assignment questions and then you will be okay to solve any question. Or you have any doubt, then I can just go through it and we can see the doubts. Or what can I do? I'll just share the PPT and I'll just quickly go through the PPT which we have seen and discuss some of the question. I'll just go through. Okay, is it fine?
Yes, sir.
Okay, I'll quickly go through because this all I have done before only. And I'll just tell you कि these things you should take care, these things you take care. Okay, fine. My screen is visible, na? Hello.
Yes, sir.
Okay, 1 second. Okay, so we are going from the week 1 to week 8. Will be going very fast because we don't have much time so that we can cover everything. This has been covered every week. I have discussed every concept before, and just now I'll just go and I'll just brief you basics things. I just revision type of things, and in case of any doubt, you please stop me and ask the doubts. Okay. Okay, then in week 1 we have seen about the deformation of metals, mechanics of plastic deformation, various machining process, single tool type of chips. We have seen this in week 1. 1 second. Okay, so we have seen in about the elastic deformation, plastic deformation. What is elastic? What is plastic? We have seen everything. This everything. Okay, what happens in elastic deformation? What happens in plastic deformation? And we do tensile testing. Why this dog bone structure is used, and Then those who have attended the class or have seen the recorded class, they know ki what I am talking about, because this has been discussed very thoroughly in very brief manner. So I don't want to discuss it once again. I just want to go through the slides so that you can have any doubt, then you stop me and ask. Fine. So we have seen about the stress strain curve, how the elastic deformation start, and after yield point the plastic deformation is there, and then the breaking point comes. We have seen about the stress strain curve of a mild steel. There is the elastic point, there is the upper yield point, lower yield point, strain hardening region, and the breaking point. This all we have seen. We have seen what is the difference between the brittle material and ductile material. Brittle material have a very high elasticity, but the ductile material have a very high toughness. This all we have seen. We have seen the difference in formula for elastic region and plastic region, right? We have seen what is strain hardening, what is necking, and how what happens in the necking. The epsilon, which is the strain, become equal to the n, which is the strain hardening coefficient, and then definition of stress and definition of strain. Acha, you have any instruction that you will have a multiple choice questions only, right?
Yes, sir.
Like it's online only or offline?
Online, sir.
Okay, so like you have to go to any center or
Yes, sir. We have to go to the center and give the exam there
right?
in their
So
online PC.
online, right? So you will not be asked any derivation and something, right?
Yes, sir.
Okay. So you should remember the formula. Each and every formula you should remember, like stress formula, strain formula, right? This Young's modulus, what is strain upon strain. This formula and all you should remember. This formula is very important. Like this formula, you note what I am telling important. Please note it. This formula of true stress and true strain is very important. This will come for sure. This will come for sure to calculate the true stress and true strain, where sigma is equal to S1 plus E, where sigma is the true stress, S is the engineering stress, and epsilon is the true strain, and E is the engineering strain. This formula is very important. It will come for sure. So please mark it. I have already explained why true stress curve is different from the true engineering stress curve. This has been already explained. Okay. These two criteria is very important, one Mises criteria and a Tresca criteria. This is for the failure theories. This the question based on this criteria we have seen already, right? And this will come for sure. One question will come from this for according to me. This one Mises criteria, this criteria, and Tresca criteria. If you have not written, please take the screenshot or just take a photo. Please this two criteria formula you should know. Okay. So that true stress strain formula and this von Mises criteria and Tresca criteria formula. This you should know. This is very important. Okay, fine. And then I have told about the machining process, which is very common, which is not required now. This formula is also important. The normal force in a wedge shaped tool. What is the normal force? So normal force is equal to the the applied force upon 2 sine alpha by 2, where alpha is the total wedge angle, so half angle we are taking. So this formula is also very important. Fn is equal to Fe upon 2 sine alpha by 2, where alpha is a complete angle, so half we are taking. If complete angle is 2 alpha, then we'll take here alpha. So this you need to know. Fine.
Yes, sir.
Any in case of this, see this I have taught very slowly and very clearly before, so I'm going fast, but still if you have any doubt, please stop me and ask so that I can clear it. Who have joined today, who have joined for the first time, they can stop clearly and ask. Okay. Or I have the this all recorded video in the YouTube channel, you can see from there. This all I have discussed, the directrix generatrix part. Machining, orthogonal cutting we have seen. What is orthogonal cutting, what is oblique cutting, we have seen everything, right? Types of chips form we have seen, discontinuous chips, continuous chip, build up edge. We know what is build up edge formation, what are the factors responsible for the build up edge formation. We have seen this is very important theory. What are the factors responsible for build up edge? Low cutting speed, high depth of cut and feed, insufficient lubrication, negative rake angle. This is very important. Factor responsible for the build up edge formation. This is very important. Please note it. That true stress, say, so what I'm going to do now, for every week which I have taught, I'll tell you the important thing. So in this, one is important is the true stress true strain relation. Second is the that von Mises criteria and Tresca criteria, and third is this build up edge formation factor responsible. This from this theory question you can get. Okay, fine. And then this other and chip breakers. So we have seen why chip breakers are used. Chip breakers are used for the ductile materials only because the long and continuous chips are formed. So to cut it. So why we need chip breaker? This you need to see for safety of operator, for improved surface finish, for easy chip disposal. This you need to see. This all we have discussed. These are the questions now. So this question we have already discussed. I am not going to discuss the question again. So in this week, you need to see one important thing is the true stress, true strain curve, true stress, true strain formula. है ना? How to calculate true stress and normal engineering stress and engineering strain. Please note it if you want. Normal engineering stress and engineering strain formula, true stress, true strain formula, and third is, so I'll write here. Wait, 1 second. See, one is engineering stress. Engineering stress is how much? Force upon area, F upon area, right? One is engineering strain, which is E, which is equal to what? Change in length, मतलब del L upon original length. Fine. Third is engineering stress, which is sigma, which is equal to S 1 plus E. And fourth is epsilon, which is the engineering strain, which is ln 1 plus E. Fine. So this four formula you should remember in case of stress strain, and then one you should remember which is fifth, which is von Mises criteria, von Mises criteria, and sixth is the Tresca criteria. Tresca criteria. So this you have to learn, and seventh you should see the this built up edge BUE, built up edge formation factors, and eighth is the this chip breaker one. Chip breaker. Okay, so this is enough for the week one. If this you know, I think week one, whatever are the concept of week one, that will be very easy for you. Okay, is it fine?
Yes, sir.
This all you these things you should remember. Now we are going to the week two. If you have any doubt regarding any assignment problem or anything, you can ask now. See, this is one of the very important question which I have already also discussed before also. Ki magnitude of engineering stress is always more than of the true stress in tension test. Can you tell me this is true or false? Can anyone tell me this is true or false? Hello? 1 second. Yeah, can anyone tell me? I have discussed this earlier, na? Hello? Hello?
True, sir.
What true?
Yes, sir.
Yes.
Magnitude.
Yeah, see, when you're telling about the tension test, na, tension means you are stretching a material, right? 1 second. Tension means this is the material. You are applying a tensile force, pulling force, right? For example, P and P are applying. When you're applying this tensile force, this length will increase, right? Its length will increase, like this, it will become like this. So its length is here if L1, now it become L2. So L2 will be greater than L1, right? But the area will decrease. If area is here A1, so you have seen it has become thinner. Here is A2. Then you will see A2 is smaller than A1, right? So when you are calculating engineering stress, so engineering stress, what is engineering stress? See, the sigma is equal to S1 plus E, right? So S is engineering stress, sigma is the true stress. So if E is increasing, na, here E is increasing. What is E? E is change in length upon original length. Okay, so this is increasing. Therefore, sigma will be always greater than S. Fine. Hello.
Yes, sir.
Okay. Can you tell about the second question? It is true or false? Can anyone tell me?
Sir, false.
Why?
Because it is not less, as it will increase. It also increase with mm,
It is given in any case. So can you tell me the case in which case it is false?
For uniaxial compression test.
For uniaxial compression test, it is false or true?
False.
False. Okay. Anyone else? It is given magnitude of the strain is always less than the engineering strain. See, I'm giving you an example, right? See, when you are increasing from, for example, you are going from 1 to 2, right? 1 to 2. Okay. So your strain is how much? Strain means E value will be 2 minus 1 upon 1, which is 2, right? This is right. But your engineer this true strain value will be ln 1 plus E. Sorry, it is 1, na? Sorry, it is 1, not 2. It is 1. 2 minus 1 upon is 1. So it is ln 2. What is the value of ln 2? 0.693. Right? This
yes,
means
sir.
in case of tension, the true strain is more than the engineering strain. So therefore, magnitude of true strain is not always less than the engineering strain. You whatever you were telling, it is for tension, not for compression. In case of tension, the magnitude of true strain, sorry, always, sorry, once again. In case of tension, the true strain is less than the engineering strain. But when you see in compression, okay, sorry, I told opposite. 1 second. But in case of compression, for example, if it's going from 2 to 1, right? 2 to 1, then the engineering strain will be same, 1 minus 2 upon 2, which is around how much? Minus 0.5.
Minus 0.5.
है ना? And the this strain would be ln 1 plus E, मतलब 1 minus 0.5. So what is the value of ln 0.5? Minus 0.693. 1 second.
Yes, sir. Minus 0.69.
Minus 0.693. Okay. But here the magnitude is not, if you see only magnitude, the magnitude is not same. The magnitude is larger than the normal strain, right? The magnitude of the true strain is always less than the engineering strain. In this case, it is not less than. When you see the true value, then it is less than. But but the magnitude is not less than, right? Hello,
Yes, sir.
you understood this? Hello.
Yes, sir.
See, in previous case what happens, see, I'll just brief it in easy, it would be easy. See, one case is of tension, right? One case is of compression, right? Here we are going from 1 to 2, and here we are going from 2 to 1, right? So here the value of E was how much? How much? 1, and the epsilon was 0.693. Okay, here the value of E was minus zero point -0.5 and epsilon was minus 0.693, right? Right?
Yes, sir. Yes, sir.
So in this case we have seen that true strain magnitude is less than this. It is right. But here we will see, if we see only magnitude, the true strain is not less, no, it is more. It is 0.693, 0.5. In this case it is becoming wrong. Therefore this statement is wrong. If it would have asked, if it would have not asked about the magnitude, then we can say it is right, because the in if we consider the minus sign, then it is less than this, right?
Yes, sir.
Okay, okay, fine, then we'll go to next week topic. So in week 2 we have covered the tool geometry, conversion of tool angles, and mechanics of orthogonal cutting. This was the most difficult, part. One second, someone has joined. So in this we have seen about various tool spaces, what are the tool nomenclatures, what are the various tool angles, side and bake rack angle, relief angle, side cutting angle, nose edge radius. We have seen this already. You have any doubt regarding this, please watch the recorded video for the concept. But today we will not discuss the concept, we will just discuss the important things. And we have seen the various angles, how they are calculated, what are the physical significance and everything. We have seen the ASA tool signature. We have seen how they are converted, how this designation you should remember. This designation you should remember. Like for it can ask the question directly in ASA tool signature. You would be given some of the angles, and they would ask which is the side rake angle. You should know what is the designation. First come the break rake angle, and the side rake angle, and the end relief angle, and side relief angle, then end cutting edge angle, then side cutting edge angle, and then nose radius. And this nose radius is in inch. This nose radius is in inch. Remember this. This R is in inch. Okay. So this you should remember. Fine. Then comes the but this is ASA system. Then is the ORS system. I have already explained what is the orthogonal plane, what is the cutting plane. This I have explained already. Here the system is different. Here comes the inclination angle, then orthogonal rake angle, then principal flank angle, then auxiliary flank angle, then auxiliary cutting edge angle, principal cutting edge angle, and R. This R is in mm. So this designation also you should remember. It can come directly question from here. Okay. Then come the NRS simple. In NRS also you have a different designation. You should remember this. Here also R is in mm. You should remember this. So this all three reference system, which is ASA, ORS, and NRS. You should remember everything, right? The designation, which angle is coming first. It can come directly in exam. Now conversion. These are the most important formula. Most very important. These are the very important formulas. The direct question is coming from this. This two is very important, and this two. This, sorry, one second. This two, this one, and this one. It is very important. This four formula you should remember by heart. direct question can come. You will be given other angles. You will be asked to find the orthogonal rake angle. You would be given this. You would be asked to find the this uh, the inclination angle. So, and the normal rake angle, the alpha max. You would be asked to give. We have solved this question very thoroughly in the assignment part. We have discussed this very well. Okay, so this you need to remember. And then I have explained about the value of r. What is the value of r? Sine phi upon cos phi minus alpha. This we have seen. The shear strength value we have seen. These are the basic formula you should remember, because these are the very basic formula which can be asked. Then merchant circle, this is very important. The question will come from here, definitely from merchant circle. You will be given some values of Fc and Ft, and you would be asked to calculate the value of other forces. Okay. Then this formula is very important to calculate mu, which is a coefficient of friction. This formula will definitely they will ask, and they will ask about this Fs also. Okay, what is the value of the this friction force? Sorry, shear force, which is Wt1 tau is by sine phi. This formula is also very important. So this all we have discussed already. So you have any doubt, then we will discuss. Otherwise, I'm just telling you these are the important formulas you should remember. Right? For minimum power, this value is coming. Now comes the questions. So basically, I want to tell in this particular section, you first remember the designation of ASA, ORS and NRS. Second is the tool conversion formulas. Tool conversion formulas. You need to know what is the formula for the orthogonal rake angle, inclination angle, normal angle, maximum rake angle. This formula you should remember. They will come for sure, right? And then you should remember basic formula of R, then shear strain rate and everything. Okay, this formula you should remember. These are very important. And then the merchant circle diagram, MCD, merchant circle diagram. Here every force, F, N, Fs, Fn, Fc, Ft, mu, this all formula you should remember. Question will directly come from this. Like, see, the question paper will not be very difficult. If you remember every formulas, you will directly get the question. So please by heart the formulas, and just because there is nothing as difficult they will ask. The question they have asked in assignment, the same level question they will ask in exam. Just you should remember the formulas. Okay. Hello.
Yes, sir.
So if anyone having any doubt, please tell me. We will discuss regarding this any concept or any this numerical, anything you have any doubt, please discuss. Simple question is there. Simple question based on formula only. I'm not going to discuss every problem because it will take so much time, because I have discussed it already. For example, see the orthogonal rake angle. The orthogonal rake angle is how much? Alpha naught. Alpha naught is given 5 degrees. Normal rake angle. Normal rake angle is alpha n, which is given 5 degrees. What is inclination angle? I, which is I. So we know that tan alpha n equals to tan alpha naught into cos I. Okay, we know this formula. So this both are same. Then cos I will become equal to 1. Then I is equal to 0 degree. This is how you solve. So the inclination angle is 0 degrees. Fine. So you can solve like this. You just need to remember the formulas. The rest are the same. There is nothing to solve very difficult. Okay. Now we'll move to the big three, which I have discussed already, about the strains and stresses, experimental study and force analysis. This formula we have discussed already, and this is not required. There are some of the models which you need to remember, like the Coulomb's law. This formula you need to remember. You need to remember this, the friction factor formula. Second, And third, this Vaughan and Bay friction model. This can also be asked. So this three formula you need to remember, because in your assignment also these questions were there, right? From the friction factor and from the Veblen and Bay friction model, right? Hello.
Yes, sir.
So this you need to remember, because without remembering this you can't go and drive there, right? You should to by heart these formulas, because they can ask you directly. Then this shear stress, normal stress formulas, this you need to remember. The shear strain formula, this formula you need to remember. What is zeta and all, everything you need to remember. The velocity triangle, this I have taught. This formula, everything I have taught. I have discussed already in brief everything. This you need to remember. What is the chip velocity? What is shear velocity? How to calculate that? This is a very important formula. 10 phi formula. 10 phi is equal to r cos alpha 1 minus r sin alpha. This is very important formula. Question will come from this formula for sure. You should remember this formula. Minimum power consumption concept I have told you. In case of minimum power consumption is phi is equal to pi by 4 alpha by 2. This concept question can come, and this is not required. This one question is can come from Lee-Schaeffler slip line theory. What is the force, cutting force in the case of Lee-Schaeffler slip line theory? This can come. This was the question in assignment also. We have also discussed this question. And then these are the theory part. In the deformation of chips, what is the formula you can calculate? E1, E2 and E3. This you can calculate in the elliptical form deformation. And the uncut length of the, you can also, this L1, this formula also we have discussed. What is the value of the uncut length of chip thickness? Uncut chip thickness, uncut chip length. So W upon rho T1 W1. So this you can calculate, where T1 is equal to this F cos psi and W is equal to D by cos psi. So this all you can discuss, right? So this you can see. These are basically every formula. There is nothing to not teach these things. We have already taught this thing. If you have any doubt in the concept part, to either ask me now or you can refer to my video, YouTube videos. If anyone is new and they don't know, then I have this channel called Abhishek's NPTEL tutorial, in which I have discuss each and everything with the questions. So if you want the solution for the, if you want to practice the question, you can just go to the channel and just see the how it is solved, the questions. So you'll have a revision. The best way to revise now for tomorrow exam is that just either you open the assignment problems, you have the solution also right now. Do you have the solution for the assignment problem now?
Yes, sir. It is uploaded on
Uploaded,
NPTEL.
na? So
Yes.
just see the question, don't practice it, because you don't have much time to solve each and every question. Just see the question and practice it. Just see the question and see the solution. It will get revised automatically. So do this. Just see the question, see the solution, see the question, see the solution. And remember, if you want to revise it, just write each and every formula in a paper. This is the best way to revise. Write the formula in a piece of paper without seeing, so that you will be confident about that you remember the formula. Okay. And then the strain rate formula. This I have also discussed. It can also come a 1 marks question. What are the strain rate and and the velocity relationships? This we have already practiced. So you have any doubt till now, which I have just shown you in brief? Anyone?
No, sir.
Okay. Then in week 4 we have discussed about the mechanics of oblique cutting and measuring of cutting forces. So in which we have seen what are oblique cutting and how the chip deviation angle, rake angle differs. This is the effective rake angle. This is very important. This formula is very important. The effective rake angle formula. So this from this formula one question can come. You would have given other thing. They will ask you to calculate the effective rake angle. This is one of the very important formulas. Okay. And normal and effective shear plane, this is the shear this shear angle formula, normal shear angle. and effective rake angle. This formula we have already discussed. You can see this also. I know there are lots of formula, but there is no way, other way to solve the question. You just need to remember the formulas. And I have also discussed about the forces, the radial force, the cutting force, the feed force, and the resultant of force is the under root of the feed square plus radius square plus cutting square. So this you need to know. Then this is not important. This I have already discussed. In actually loaded member, what is the value of strain? How to calculate the value of strain? In cantilever beam, what is the value of strain? In the rings, what is the value of strains? In how to calculate the cutting force in case of cantilever elastic deflection. This we have this gauge factor. This is a very important formula. This gauge factor is, you please remember this formula. This is very important. This is important. The gauge factor is equal to del r upon epsilon. So this you need to, where epsilon is about, epsilon is strain only, na? It is del L by L. So this you need to remember. These are the very important things which can come. This gauge factor question can come definitely. So please, please try to look to these formulas. So now the question is there. So see, for example, in oblique cutting, the inclination angle, which is I is equal to 5 degrees. I always say what is given first, right? Chip flow angle. Chip flow angle, which is the rho c. 1 second. Which is given 6 degrees. Effective rake angle, effective alpha E is given 8 degrees. So what is the normal rake angle? Alpha N. Okay, so we have the formula. What is the formula? 10 alpha E is equal to, 1 second. Sorry, sine it is. 1 second. Sorry, it's not 10, it is sine. Sine alpha E is equal to cos I and cos I into cos lambda, cos this into cos this, cos rho into sine alpha n plus sine I into sine rho. So everything is given. You just need to find alpha n. So this type question will only come. Everything is given. You just need to find this alpha n. Like this, if you remember the formula, you will easily solve the questions. Like this, different questions are given. We have already solved each and every questions. Now coming to week 5 content, in which we have seen about the thermal aspects of machining, tool wear and tool life, optimization of machining processes, in which we have seen about the various chip shear zones. These are all theory question. We have seen about the power and other power dissipation formulas and everything. We have seen about this variation of temperature with the cut speed and the depth of cut. These effects of tool geometry. These are the all theory question. We have seen about tool rake angle variation with tool temperature, clearance angle variation with the tool temperature, the cutting temperature variation with cutting edge angle, temperature variation with the nose radius. We have seen everything this. Then we have seen different types of wear, tool wear, and we have seen about flank wear, cutter wear. How does the flank wear wears? How does the cutter wear wears? This all we have seen. Tool life, Taylor's tool life. This is very important. This is very important. Taylor tool life equation. This is very important. This will come for sure. One question from Taylor tool life equation will come for sure. So please, please take care of this. Modified Taylor equation also, in where the feed and depth of cut contribution also come into play. So we have seen that rake angle, variation of rake. These are all theory questions. Flank angle, variation of flank angle with tool life. Side cutting edge angle, variation of tool life with side cutting edge angle. This all we have seen. And then we have seen the optimization criteria, the minimum cost per component, maximum production rate, maximum profit rate criteria. This all we have seen. This we have seen. These two formulas are very important. Very important. This one question can from this formula also. For the, what is the optimum cutting speed for maximum production and optimum tool life for maximum production? This will come for sure. Okay, so this will come. You need to remember this formula. This is very important formula. Now the question part. So just to remember the formula, and every question is very easy. We have discussed each and every question. If you are having doubt or some like you will not able to solve, just uh, take out your assignment solution, see the question, try to think how to solve it, which formula to use, think yourself, and then see the solution. This way you can revise today. This is the best way to revise very fast and very effectively. See the question, don't see the solution, think what you can do, think the formula, if possible write the formula in paper and then see the solution. Oh, this has to be done like this only. Then you can revise it. Now the week 6 content, in which we have seen the turning process, milling, drilling, grinding process. And we have discussed each and everything about what are turning processes, different turning processes, the theory behind a turning process, what is turning process. We have seen the video also. This formula you should remember. What is the formula of cutting speed? What is the formula of feed velocity? What is the formula of the undeformed chip thickness? This formula you should remember. What is the formula of undeformed chip width? So 4 formulas are there in turning, right? Then power formula. What is the formula of power in turning? Which is Fp into V. This you should know. Then specific cutting energy. This is very important formula. It is very important. What is the form? This you can ask to find the specific cutting energy, which is the power upon the MRR, where MRR is this pi dn into FD. This you should know. Surface finish. What is the value of surface finish? So this I have already told about the RMS value, central value, highest value. Everything I have discussed. This formula is very important. I have informed for the sharp tools this is used, and for the tool with the cutting edge radius this is used. This formula is very important. This one question from this will definitely come. If you are using the cutting tool with a edge radius R, then this formula is used. If you take using a very sharp tool, then this formula is used. These two formulas are very important in case of surface roughness, surface finish. Okay. This is very important. Then shaping, planning, this all I have discussed. Milling I have discussed. What is milling, up milling, down milling, everything I have discussed. What is difference between up milling and down milling? So this formula you should remember. The in plane milling, the value of the undeformed chip thickness, it is very important. And this formula is very important. In place of plane milling, what is the value of the undeformed chip thickness? Okay. And face milling, this is also what is the value of the undeformed chip thickness. This is also very important. Surface roughness in case of milling. This is very important. So please remember this formula. What is the value of surface roughness in case of plane milling? So V square upon pi d n square n square. 4d n square n square. This you please remember. Then comes the drilling. In drilling also we have discussed about the various formulas which is required. Like the normal rake angle drilling formula. This. Then we have discussed about this undeformed chip thickness, chip width. These are very important in case of drilling. Rest was not very important. And in grinding, like in grinding, this is very important. This is very important. I have discussed in last class. This nomenclature is very important. You need to remember this. What is A stands for, what is grain size, grain type, grade, wheel structure, bond type. This you need to remember. If A, then it is aluminum oxide. If C, then it is silicon carbide. In grain size from 10 to 24 it is coarse, then 30 it is medium. It depends upon this only. And for grade J, what we, so this you need to remember. This is very important. For example, one question was there in drilling. In this question was there in grinding. This what is the which grinding wheel is used? So A is there. A is for aluminum oxide. So either it is aluminum oxide. Okay, and A50 is there. So what is for 50? 50 is for C. 50 is for this medium. So it is medium. Aluminum oxide medium. Okay, so like this we need to sort aluminum oxide and fine. It is not fine, it is medium. So it is B or C, and then it is given M5. So what is M5 here? Okay. Now M5 and R. See, M5 is what? 1 second. See, M5. So 5 is to normal, not dense. And M is here medium. So medium, normal, and R is for rubber. R is for rubber, right? 1 second. So here M is medium, 5 is normal, and R is for rubber. Answer will be A. So like this you need to remember and solve the question. Okay. And the week 7 content was the surface finishing content. These were all theory questions. All theory question about the surface finish, ideal roughness, this we have discussed. All theory questions. Lapping, honing, surface finishing, polish. This I have discussed each and everything. This is all you need to remember because this is because all theory, no numerical in this. What is lapping? What are the various process parameters in case of lapping? What is honing? What are the various process parameters in case of honing? What is super finishing, process parameter in super finishing, polishing, buffing, CNC. This CNC I have discussed very thoroughly. How to write the program, what are the various G codes and M codes. I have discussed very strongly. I have discussed. What are the various G codes and what to write, what to not write. This is very important. I have discussed the linear interpolation and the counter clock interpolation. This is very important. Right, see, I'll discuss this once more because this is very important. Like if you want to go from one point, this 1 to 2, this is linear line, right? Then you always write, and you are going on a linear, you write 0 G01. It is for the linear interpolation. And always write the final position. Final is x5 and y12, and then the feed, by how much feed you are going. This is very important. In this case, you are going from, see, 1 to 2. Right, so there are two ways to write it. Either write the radius wise or the center wise. When you are writing the center wise, then it is, see, you are going anti-clockwise, it will be G03. G02 is for clockwise, here you are going anti-clockwise, na? So G03. Then final position is x0 y7, and see what is the radius. Radius is 5, so just write R5. This is the radius way of writing the code. But when you are writing in terms of ij, which are the centers, then you will write G03, X0, Y7, and see, you have to write in case of I and J. What are I and J? I and J, see, I is the distance from the center to the X distance from the center to the initial position. So this is center. This is center. See, I'll draw it. Wait, I'll draw it. One point is here, one point is here. You are going from like this. This is how much? 5 comma 12. 5 comma 12, and this is 0 comma 7, right? This is center. This is center. This is center. This is A. This is B. This is center. So center region is 5 comma 7. Okay. So I is the x distance of C, the x distance between the C and the A. See, A and C lies on the same line, right? They are lie on the same line, so there will be no x distance. So x distance will be 0 in this case. And the y distance between A and C is, see, this much. This is the y distance, which is 12 minus 7, which is 5. But we are going from A to C down, so you will write minus 5 because you are going down. If you are going up, you will write plus 5. So the code will be I0 and J minus 5. Understood this? This is clear? Hello?
Yes, sir.
Okay, so this we have already discussed before. This is one of the complicated thing which they can ask you, and they will definitely ask you this. So be prepared. They will definitely ask you this, either the radius wise or this IJ form. You have any doubt, please ask me. I'll explain again. Okay, then we'll move forward. This for the various codes you need to ask. You need to just remember the codes, G code, M code, remember, and this you remember. And the week 8 content was the advanced machining process. Like I have uploaded this video. Have you seen this video in YouTube? Hello?
Yes, sir.
Okay, I have uploaded it later. Okay, in this we have seen about various advanced mechanical process. This all theory. This is all theory. Ultrasonic machining, then abrasive jet machining. What are the various process parameter? Water jet machinings and AWJM, abrasive flow machining. These are all theory process. There is no numerical from this question. EDM, ECM, wire EDM, electron beam machining, the laser beam machining, and the plasma arc cutting, electron chemical machining, the chemical machining. These are all. So this theory questions only you need to see. There's nothing to be taught here. So this were the like brief. I have covered what are the things and what are the important things. If anyone having any doubt, please tell me. We will cover. Doubt can be the theoretical doubt also or the numerical doubt also. Any doubt in the assignment, any doubt from the assignment, from the theory, from the numerical, any doubt, please tell me. We will discuss here and then we will close it, because you need to study also for your exam. So I'm giving you 5 minutes. Please tell me what are doubts you have so that we can discuss, or any concept you want to see again. Please tell me. Please think once. I'm giving you 5 minutes and then we'll discuss it. So okay then. If you don't have any doubts, so we will close it. Hello, hello.
Yes, sir.
Okay then, all the best for your exams. Just before going to exam today, as I said, just see your assignment problem, because your assignment problem covered each and everything. So if you'll give 2 hours also, then you will see each and every questions. Don't solve it. Just see the question. Uh, uh, don't see the solution. Remember yourself how you can solve it. Write the formulas and then see the solution. You will give 2.5 hours also. You can see each and every questions. And okay, so we can close it now.
Yes, sir.
Okay, thank you so much for attending. It was a very nice session, and you have patiently seen each and every video and attended each and every classes. Hope it helped you, and I hope I have done well to teach you, and you understood everything or something which I have told you. And all the very best for your exams.
Thank you, sir.
Okay, all the very best. If you have any doubt, then one second. If you have any doubt, mine one second. One second. This is my number. My name is Abhishek. 7049881319. This is my number. You can text me, you can WhatsApp me, you can even call me. If you have any doubt, please free to call me or text me. I'll be there to help you. And I hope you'll do well and all the very best.
Thank you, sir.
Okay. Thank you. Have a good day.